In this particular question, a parallel plate capacitor is charged to a particular potential difference V. It is disconnected, then distance between the plates is doubled. So D in the second case become 2 times of D in the first case. With reason, explain how the following factors change. Charge stored in each plate of the capacitor, capacitance of the capacitor, energy stored in the capacitor, potential difference between the plates of the capacitor, electric field between the plates of the capacitor. So these type of questions, so particular category, we need to use some formulas related to the capacitor. So the basic formula for any capacitor is charge equal to capacitance into potential difference. So Q equal to CV. Even can be used as V equal to Q by C for calculating V if you know Q and C. It depends what all you know. C and V, you know, you can use Q equal to CV. Q and C, you can find V as Q by C. Same way in capacitors, we use V equal to E into D. Same way, if it's needed, you can find E as V by D also as per the availability of the factors. E and D are available, you can multiply E and D to get V. If V and D are available, you can take the ratio of V to D to get it. Same way, electric field between the plates, another formula we have. Sigma by epsilon 0. Sigma is charged by area, Q by A should be Q by A epsilon 0. So you have two options for finding electric field here. You have two options for finding potential difference here. Same way, even energy when you find for a capacitor, we have three options: half CV square, Q square by 2C, and Q into V by 2. When there are multiple options for one particular quantity like V, E or U, the equation to be selected is always with maximum number of constants. If in a particular case, there's a charge remains constant, so you should select equations involving charge. Instead of that, if they say potential difference remains constant, so select the equations which involve potential difference. So that's a way if multiple options are available for a particular question with formulas, the formula which include maximum number of constants should be selected for solving or explaining that particular question. Now, other than these two, these formulas, there are two more points to be clear with the type of questions. Number one, if a capacitor is charged and disconnected. Disconnected means it don't have any connection with any other voltage source or any other external circuit. So whatever charge stored inside the capacitor will remain the same. A capacitor which is charged and disconnected. Charged and disconnected. You can't change the charge. The charge stored in the capacitor will remain the same. The other factors can change. Same way, second point, if a capacitor remains connected to a cell, after charging, even it remains connected to the cell throughout. So the potential difference across the capacitor will be same as that of the cell. It won't change. So if capacitor remains connected to a cell, potential difference across the capacitor will be same as that of the potential difference of the cell. That means potential difference remains constant across the capacitor if cell is remaining connected to the capacitor. These are the two important points. If it's connected and disconnected, the other factors may change, but these factors as per the situation remains constant. So these two facts along with these formulas, and I told you which formula to be selected for solving which particular type of questions will help you to solve this. So number one, after the background information, charge stored in each plate. If you read the question, it's disconnected. So disconnected, we already know charge remains constant. That means Q2 and Q1 both are same, since the capacitor is disconnected from the source, which is cell. So Q2 equal to Q1, which is same as Q. Capacitor is disconnected from the source. So no addition, no loss of charge from the capacitor because no connection. Now second one, capacitance. If you know formula for capacitance, that has to be added here, C equal to A epsilon 0 by D. So capacitance formula, C is A epsilon 0 by D. Case 1, C1 is A epsilon 0 by D1 because the distance is only changing here. A is not changing, the medium is not changing. Distance, second case become 2 times of the first one. So C2 will be A epsilon 0 by D2 because the other factors remaining same, only distance is changing. Now D2 can be replaced as 2D1. So A epsilon 0 by D1 will be same as C1. So if you take this 2 out, 1 by 2 times of C1. That means C1 by 2. So the new capacitance becomes half of the initial capacitance. The second one, third one, energy. Energy, there are 3 formulas. Q square by 2C, QV by 2, half CV square. In this, charge remains constant. So I'm leaving half CV square. I'm going for Q square by 2C because here Q is constant and C change already we know. So U1 is Q square by 2C1. U2 will be Q square by 2C2. Now C2, the change we know, C2 becomes C1 by 2. So C1 will come here, 2 will go on the top. So Q square by 2, C1 by 2. So why this 2 is not cancelled? Because for replacing Q square by 2 C1 as U1, you need this 2 here. So you can replace this Q square by 2 C1 as U1. So it will be U1 into 2. Means energy becomes double basically. Now the fourth one, potential difference. Potential difference, you have 2 options. E into D, Q by C. We already know Q is constant and C. So this is the best option for finding the potential difference. V1 is Q by C1. As Q is constant, only C is changing. Now V2 is Q by C2. You can substitute C2 as C1 by 2. So C1 will remain, 2 will go on the top. So Q by C1. Q by C1 is same as V1. So V2 will be 2 times of V1. Potential difference becomes double. So the last one, electric field between the plates. Electric field, you can have either V by D because V change we know, D also the change we know. But the best option still, electric field between the plates of the capacitor sigma by epsilon 0, which can be Q by A epsilon 0. And if you check all the factors in that, Q remains constant, A remains constant. There is no medium introduced, so epsilon 0 also don't change. So all these factors are constants. Means electric field don't change. That will be E2 equal to E1. So these are the changes in the factors, what they asked with the explanation. The mathematical part will be the explanation. The formula to be added, I just used one extra formula along with this. C capacitance is equal to A epsilon 0 by D. This also added with the set of formulas. It completes the set of formula used for that.